Yes, quite. You see, with this I capture the power of the sun to send a beam of precisely controlled light to a far land.
Yes, it's that classic TV and movie cliche. Add a gemstone to any source of light and you instantly get a laser, whether it be Star Wars, MacGyver, Indiana Jones, or James Bond. It always seems to work like that. But you can't just put a ruby at the end of a flashlight and write your name on the moon with a laser, can you? Science doesn't work like that. Or does it? Turns out, science actually does work like that. Allow me to shed some light on the situation. See, both synthetic rubies and sapphires can be used to create lasers, since rubies and sapphires are basically made out of the same thing, a mineral called corundum. Now, corundum is mostly alumina, Al2O3 for my chemist friends. The main difference between a ruby and a sapphire is the metallic impurities that cause the color. Now, rubies have chromium impurities, which causes the red color. Sapphires, on the other hand, can have any number of impurities, iron, titanium, chromium, copper, or magnesium, which gives it either the blue or one of the other colors that sapphires are usually found in. Now, to understand how we can get a laser out of a ruby or sapphire, we have to understand how solid-state lasers work. The corundum used in the solid-state laser is doped with a transition metal like titanium or chromium. Now, I know what you're thinking, that's one dope ruby. What doping actually means is just adding an impurity into the crystal structure. The next part of generating a laser with a ruby or sapphire is the optical pump. Think of the optical pump like the flash on a camera. When this flash goes off, it energizes the electrons, makes them in an excited state, just like when things start strobing at a rave when you and your friends are partying. Now, when that electron stops being excited, it goes from a high energy level to a low energy level, and when this happens, a photon is released. Now, this photon careens into other electrons, causing them to get excited, which also release other photons. And with all these photons bouncing around, it creates a chain reaction which generates all the light needed for your laser. Recently, scientists have figured out a way to generate a laser using a diamond. However, most of the time, diamonds are used for laser lenses rather than the laser generation medium itself. This is because diamonds don't break, corrode, melt, or dissolve when used in high-powered lasers, which makes them excellent in harsh conditions. By using chemical vapor deposition, we can actually grow our own diamond lenses now, much cheaper than if we had to use natural diamonds. Because of this, diamond lenses are appearing more and more in laser applications. So did Hollywood actually get this one right? Well, kind of. Synthetic rubies and sapphires can be used for lasers, but natural rubies and sapphires have far too many impurities in order to act as a lasing medium. This has been Mentallurgy. Thank you for watching. My name is Tyler Priel. If you'd like to continue forging a smarter tomorrow with us, please hit the subscribe button. I think it's there now. YouTube moved it recently. Oh, and if you have a suggestion for a future episode, please write it down in the comments below.